Day 29, page 712, number 10. This is a basic parallel circuit, but they have a couple of meters indicated for taking measurements, and they're saying that they're ideal meters, which means they do not affect the circuit. They're not taking energy out of the circuit. Interestingly enough, when you use an ammeter, you hook it up in series, as you see in the diagram, with the 4 ohm resistor. But internally to the ammeter, there's a parallel circuit, because what you need is a low resistance in that meter overall. And the galvanometer, symbolized with the letter G, is the device that takes the measurement. And it needs a little current to go through it to actually take a measurement. But overall, you want the meter to have a small amount of resistance, so you put a very small resistor in parallel with the galvanometer, so the meter in sum total has very, very small resistance, even though a little bit of current will go through the galvanometer and take a reading. So it does affect the circuit to a small degree, but hopefully not enough to change the circuit at all. It's kind of like using a thermometer to measure a glass of water, the temperature. The thermometer itself should not, it does have a little impact on the temperature of the water if it doesn't start off with the temperature of the water, but it should have an insignificant amount of effect on measuring the temperature of the glass of water. And for the galvanometer, or for the voltmeter, there's the galvanometer in series with the resistor, because you want the voltmeter to be hooked up in parallel with whatever you're measuring, and you want very little current to go through the meter in total. So G, the galvanometer, is going to get a small amount of current again, not enough to affect the circuit, but it will take a measurement. Once again, this is a basic parallel circuit. So every element here, all 3 resistors and a battery, all have the same voltage, potential difference. And in the one branch there, it says that the ammeter has a reading of 3.20 amps. So it's just basically Ohm's law, V equals IR. I can apply it to that one branch, and that's just going to be the current that's given, 3.2 amps, times the resistance, 4 ohms. So you get the potential difference. The voltage there is going to be 12.8 volts in that branch, which is the same for all elements there. So you can figure out the current in the other resistors. But I think they're asking what the voltmeter reads, and the voltmeter is going to read the 12.8 volts for every device in that circuit.